Hi, Ted.
Hello.
Hey, Ted.
Hello.
Good morning. Good morning.
How you doing?
Good. How are you?
I'm doing great.
Nice to see you.
You do?
Thank you for making the time this morning.
Yeah, no problem.
Yeah,
It's
this is it's the middle of December and a lot of tags have been canceling. It's not uncommon right before Christmas. So I think this might be like a really short meeting. Like we don't have a lot of people today, but we have this weird thing going on. We have like a ton of people in our Slack channel and our videos are getting a bunch of views and stuff, but we haven't been like super marketing everything the right way. So we're talking with the TOC about how we can get better at doing that. But
Yeah. Hey, well, maybe we can coordinate because I want to really grow the OpenTelemetry YouTube channel.
yeah.
We're putting out our end user SIG has been putting out some really great content there. They've been organizing stuff, including Henrik, who's
Hi,
been
Henrik.
great at creating content and helping us organize. So we were actually
Yes.
talking at KubeCon, like we need to like become proper YouTube moguls and
I know.
yeah,
actually get a
YouTubers.
game plan together around like how are we going to release content on some schedule and market it and maybe even get a little budget to boost or goose, right? Seems like it's
Yeah.
play
Yeah. I mean,
stays.
people do catch up on the videos for sure, Ted, because
But
you know,
I
so
mean, but when I look at the views, they could be higher, and I believe that we could grow subscribers because
agreed.
I think like I don't know about the tag channel, but certainly for OpenTelemetry, like I think we've got like good content, and we're not spamming people with like meeting notes and stuff like that
Yes,
anymore. And
exactly.
so I think we could grow a subscriber base, you know.
for
Yeah,
sure.
we are currently rebranding the hotel in practice to hotel in me. So we create the event Austin gave me the admin rights to the YouTube channel. So now I will be the shadow guy in the background producing
Nice.
it. So to make it more a nicer experience for the attendees to join in those type of meetings. I think
Nice.
it's because I think watching a Zoom call makes it less attractive or less modern, or I don't know. And
It's too lo-fi. Yeah,
yeah, yeah,
for
Yeah,
sure. Like a minimal amount of production value to make like YouTube live work for us and
yeah.
stuff like that would be so good.
yeah, stuff like common like lead-ins and I don't know, music or I don't know. Henrik has a lot of experience from his channel. I've seen, like a lot goes into producing content in a way that's consumable and palatable to the non-religious folks who don't just like, oh, a Zoom meeting, I'm gonna watch it all because that's what I do. Like I think I'm dated myself a little bit. I don't mind
Yeah.
that there isn't high production value. I like lo-fi, but to your point, yeah, I think we could do a lot to increase subscribers and
Yeah.
And
I did a
even if I'm
YouTube series back in the day where I put some, a little bit of elbow grease into the content production value, and it did seem like it got a more general audience, but it was like buried in the Lightstep channel and
Yeah.
yeah, and then
jackass.
also the fact that it's related to a brand, to a corporate brand, then it doesn't, I mean, people has like it's gonna be marketing. So here being part of a tag or being part of a open source project, then you're not talking about from a brand perspective, you're talking
Yeah.
for education, and I think that makes more sense.
Yeah.
Completely.
The thing I
But as
noticed is I put those out there, and it got, I think where it was living limited its views, like you were saying. But the thing I noted was I started getting a lot of engagement. Like I was getting comments on it, right? The ratio of like comments to views
Hmm.
was actually good, and it was people saying like, thank you for, making this palatable, essentially.
Very
So
cool.
really,
Very cool.
anyways, long story short, I really think there is something to having just not like slick, but just it being a little more entertaining.
Yes.
yeah,
for
Yes.
sure.
and from the tag
Absolutely. Jokes too.
and from the tag meeting when we we have a solution or someone presenting, I think we should make it more bring more entertainment, because I think if people because it's usually the demo is in the middle of a meeting, so then you're not aware that in this particular moment there is some valuable assets there, and I think we should promote it.
Like
Absolutely.
even chapters, and I had thought around like I've tried to, well, so for most of our videos I've made them searchable at least by having the summaries and the meeting notes and stuff in the talk descriptions, but we could even do better around having like annotations or labels so that I want to find out about.
No, but I like
CNCF, cloud observability, Ollie, OpenTelemetry for you to come up.
No, I think Henrik has a point. Having entertainment, in a subtle way is always fun.
Yeah.
So
Yeah.
we'll work towards that, Henrik. I mean, again, I think we can leverage that both at the project hotel layer as well as the tag layer. I mean, people to join in. So, again, it's just a question of, being a lot more, outreachy kind of.
We should
All
probably
right.
this meeting. I think we've got quorum here.
Yeah, we do.
That's Sunil. This is the mid-December meeting of TAG Observability. This is a CNCF event. Anything that you do or say should be within the scope and the policy of the CNCFs and the Linux Foundation's guidelines. I think we need to get the official thing so that I can do that a little bit more smooth. But thank you all for coming. And the only thing we really have on the agenda today is Ted. Ted's come to talk about OpenTelemetry. And well, I don't want to steal your abstract, but we're really excited that you're going to come and talk to us about OpenTelemetry's goals and where we are now that we're at the tail end of 2024.
Yeah.
Happening in a lot of different directions. If there's nothing else on the agenda that anybody else has for today, I don't have anything else. I'd say the floor is yours.
Yeah, I
Cool.
think we're ready. Ted, over to
Alrighty.
you.
Yeah, I'm happy to do this. I'm gonna, given who's showed up here, I think you might be a little bored by this talk, at least the first part, because I think it's important, I did realize that like I haven't done my this is like the why of OpenTelemetry pitch in a while, and I do think having like a bit of that background before we hop into like, well, where are we going next, is helpful. So apologies.
Absolutely. No, don't apologize. I should actually say one last thing. We've been talking over the last couple of weeks and months about, what is the tag's purpose and tags in general at the TOC level and within the community. And one thing that's happened with, not just tag observability, but some of the older tags is initially when a lot of these solutions were still being developed, like OpenTelemetry didn't exist yet. It was a fragmented user community, right? We had a lot of tools being implemented like Cortex and, Prometheus was getting from it's like 1.0, I don't scale at all to, there's all of these kind of things that we're building. And then for the last couple of years, there's really been some consolidation and observability, and some of the tools like OpenTelemetry have become ubiquitous and widespread. And the tenor of the meetings has not stopped, but has changed from like, hey, this is all new. How does it work? Should it work at all? Right? To like, now this is a thing. And we forget that there's a lot of people that their journey is just starting. Like they might not have years of background in all of this. And oftentimes content skips that first part and doesn't have context. So if you've got some stuff around that, we won't report at all. Actually, it's something we all need to get a little bit better about remembering as we welcome new community members and attract them. So by all means.
Great. Okay.
Thank you, Matt and Alerta. Hi, everyone.
Hey,
Hello.
Sunil, thanks for
Hi,
joining in.
Teddy. Sure, yeah, thank you.
Great. Oakley dokley. Hang on. Making up. Man, Google, you just fallen in love with the pop-ups, Google. just pop-ups on top of everything now. Like, why would I want to actually use your tools? Okay, let me share my screen. Okay. I hit allow. Can you see my screen? Great.
Yes.
All righty. So I'm here today to talk about OpenTelemetry and the future of observability, because we are in a midst of a sea change that's still ongoing in this industry. That, in my opinion, is kind of like the biggest we've really seen in the field of observability, at least since the invention of syslog. My name is Ted Young. I go by Tetsuo on the internet. I'm one of the co-founders and a GC member for the OpenTelemetry project. Before that, it was Open Tracing employees over at Open Tracing. But that project has since been archived because we merged with the Open Census project to create a project called OpenTelemetry. But why? Why did we do this? We did this because things need to change, right? We've been doing things a certain way for a long time, but just because we've been doing it that way doesn't necessarily make it right. I'm back. The point here is, like, where are we going? I mentioned that we're in a big shift, and OpenTelemetry is part of that shift. So to understand where we're going, let's figure out where we were in the past. In the olden days, we had this whole 3 pillars concept. And even the term 3 pillars is a bit of a joke to my mind, because it implies that there's some kind of design that was implemented, that like having these 3 separate silos of data was some kind of intentional design. I prefer to call it the 3 browser tabs of observability. But even that is like going too far, because tracing's one of those pillars or tabs, and that stuff was like so annoying to implement at the time. No one really actually used it. Man, hang on, guys. Yeah, okay. Sorry, it's been a while since I looked at these. My bad. We'll fix it in post. So what we actually want to do here is we don't want to have silos of data, right? We want to have all of this data braided together and connected into a graph that a computer could walk, right? So that humans aren't actually the ones having to be the glue between all of this. Let me explain what I mean, right? We don't use this stuff in practice in isolation, right? We use all of this data together when we're diagnosing our systems, right? We don't like have a logging problem, be like, oh, there's a logging problem, let's go look at the logs. Whoop, we got a metrics problem, let's go look at the metrics, right? We have a system problem, and we're using all of these tools together in a workflow to try to remediate those problems. And a big important part of remediating those problems is correlation, right? Something happens somewhere, and that correlates to a problem somewhere else, right? Like end users might be experiencing really extreme latency, and that latency might correlate highly with a particular server in your system. It might correlate highly with a particular version of a particular piece of software. It might correlate highly with a particular piece of logic, right? A particular user account. There's all kinds of things a problem could be correlated with. In these huge systems, trying to find those correlations is a terrible, terrible experience. Here's a good example of the kind of caveman style observability we've been doing traditionally, right? Basically, an alert happens. And what is an alert? It's basically you have some metric that's important, and it goes all squiggly. And I say squiggly because these metrics are represented as little lines, right? That's the UI that we have, like little lines traditionally. You know, I was a big Munin fan myself, but all the tools that have come since are like pretty similar. And you go look at those lines and you try to figure out which other lines went squiggly when that line went squiggly. And I've even done this, right? Like I've taken I used to keep a ruler next to my desk so I would have something to quickly line up on the screen to see which lines went squiggly. And the UIs have gotten better for these tools, of course, but that basically means like they now automatically have a line to help you see which lines went squiggly next to each other. And this is really dumb, right? We have all of these computers at our disposal, and how are we finding correlations? By using our eyeballs to look at squiggly lines. Obviously, we can do better, right? But it's not just metrics, right? Traditional logging has also suffered. And just to be clear, I'm not talking about like the products in this space or the open source projects or anything like that. There's lots of really good projects in this space that are trying their best. This is purely a problem that originates from the data being siloed. And in the case of logs, if you've got a really, really complicated system with lots and lots of services involved in a single transaction, trying to reconstruct that chain of events when you out of logs traditionally has been very, very difficult because those logs are missing a transaction ID. There's no index that you can take where you look at one log and say like, oh, here's my transaction ID, and then paste that into your log search and find the rest of your logs, right? Like, but doing that, that's literally what a tracing system does. People used to think of logs as like a record of the events in your system, and tracing was just some weird tool to look at like system latency and stuff like that. But that's really not what a tracing system is. A tracing system is really just something that staples transaction IDs onto logs. That's a much better description of what the core functionality of a tracing system. And it's not just logs and tracing where we have a problem that could be solved by merging those two tools together. Logs and metrics, same problem, right? We're often moving between looking at statistical data, like an alert, for example. So an alert happens, right? So we're seeing a change in our system in aggregate. But the next thing we want to know is like, well, what are these events that are actually occurring, right? Okay, there's a spike in 500 errors, but which 500 errors? Where are they coming from? So you naturally want to go from looking at data in aggregate to looking at transaction logs for the individual requests that are occurring in your system. So if you could actually correlate these things and do this in a way that was done in a data model so that computers could actually find these correlations instead of the humans, then you could get alerted and move quickly from the alert to the transactions. And don't worry, guys, I'm not making a product pitch. I don't even work at a company these days. The point of it is, though, we're using all of this data together. We're not using this data separately. We're moving fluidly between these different ways of looking at our system in order to understand what the heck is going on. And because of that, our observability tools are changing. Now that people have caught the bug for this, we're seeing a consolidation in this space, right? We're starting to see all the various vendors and projects and things like that think beyond just the particular silo of data they started with and are starting to think about how can I be a platform that brings all of this stuff in together. So that's the big industry shift that we're seeing right now. Like literally all of these companies and projects are changing what they do to become a more unified platform so that they can actually provide some kind of workflow to developers and operators that matches what they're doing. And in order to do that, you need data, and that data needs to be constructed properly And the data that we have chosen is OpenTelemetry, right? OpenTelemetry is the thing that brings all of this stuff together. And it worked, right? We made this project. We said, hey, why don't we standardize on a new kind of telemetry that has all of the data in one spot connected together. And the project really, really, really took off. So at this point, it's the second largest project in the CNCF by just about any metric. So that's fabulous. But is this really like the beginning, middle, and end of observability? Is it really just tracing metrics and logs, and that's all we ever needed or really wanted? Well, no, that's not true, right? There is definitely more to observability than just those three signals. So to figure that out and see where we might be heading in the future, let's have a look at something that I like to call the hamster wheel of life. So this is this little circle that we go around where we write code locally. Then we deploy that code. It goes through some kind of CI/CD system. It gets out there to prod. Life is good for a while until it isn't, at which point we get some kind of alert that something bad has happened. Then we go to town trying to find correlations between the alert we got, the symptom that we've seen, to the root cause. So correlation leads to causation, and these are two separate things. And once we've figured out the cause, then we know what code or configuration change or whatever it is we need to make to bring the system back into a healthy state. So, and then rinse, repeat, right? We deploy the new thing, solve the old problem, but then new problems show up, and we just go around this circle till we get promoted out of having to do this anymore. If we annotate this with the kind of observability that we might need, we can see there's more than just tracing metrics and logs, right? When we're going from writing code to CI/CD, there's a lot of testing involved. That's important. In all of our various deployment environments, from local all the way up to prod, there's a lot of configuration involved, right? All of these services are configured in certain ways, and how they're configured changes based on the environment that they're running in. So that's a really important source of information. When we're looking at alerts, that's data in aggregate, so that's metrics. When we're trying to find correlations, that's when we're looking at the metrics in aggregate, as well as the traces and logs. Once we've found some correlation and we want to dig deep into a particular part of our system and understand what's going on, well, you can definitely use traces and logs for that, but that stuff is pretty coarse-grained. So we're looking at profiling as a dynamic way to get much more fine-grained information about specific parts of our system. And all of that stuff feeds back into the code, right? So it's actually important to understand when we're looking at any of these signals, how that relates to the actual source code that was compiled to build that system. Because at the end of the day, that's where you're going to be, right? You're going to be in that configuration file, or you're going to be back in that source code, because that's where you do your remediation. So it all has to funnel back into that. So if we look at the future of observability from OpenTelemetry's perspective, this is how I personally see it going and where I would like to see us focus in the future. So we've got tracing metrics and logs. Those are already generally available. They're mostly complete as far as OpenTelemetry is concerned, certainly from a specification point of view. We have profiling, which is very active and in process, being brought into OpenTelemetry. A number of great organizations, a lot of great people working on that. But then we have a couple of things that we really haven't looked at yet. They're still kind of over the horizon as far as OpenTelemetry is concerned. One is configuration files. OpenTelemetry doesn't have a place in its data model right now for how you would hoover up configuration files and transmit those things to an analysis tool in an efficient or effective manner. You could take the config files and just stuff them in as resources, but that would be really, really, really expensive. So right now, OTel does not have a solution for you for how you would hoover up that data. We also don't currently have a complete solution for how to connect all of these different signals back to the original source code. We have a concept called instrumentation scope. So anytime you make any kind of instrumentation, it's scoped, and that scope has attributes. But we don't currently have tooling that sort of automatically fills out those attributes in a way that tells you precisely what source code this came from. Even if we could get it down to the level of what file it was in, or what package, or what library, there's some of that stuff is there, but it's not regularized to the point that you could just like click on something in your observability tool and have it pop open in your IDE. Connecting that dot seems really, really important for us to tackle at some point. The other thing we're missing are dev tools, right? Using observability, or observing your observability, or otherwise interacting with this stuff when you're writing code. People have been taking some good stabs at this, but there isn't anything super comprehensive there. There's a couple of command line tools that are really cool. The Aspire team at Microsoft has developed a really cool thing. But we haven't seen anything like, comprehensive IDE support for the popular IDEs like VS Code. And having OpenTelemetry integrated into that stuff with the kind of observability you would want when you're writing code would be really helpful. And the last thing that I see as important and useful is testing. We test our code using a set of tools, and then we deploy it even to a staging environment, and those testing tools are no longer available or useful to us. So there's kind of a break, like a hard gap between testing and observability. And that has always struck me as like kind of odd and not very helpful. So it would be great to see that get improved. And we've actually seen a number of open source projects and even products come out in that space, which I think is great. But I'm going to go ahead and say that, in my opinion, those kinds of testing things are probably out of scope for OpenTelemetry. I think it would be better for other organizations to focus on building those tools, in part because testing involves perhaps a lot of analysis. There's probably more than one good way to do that. And in general, OpenTelemetry tries to stay out of the analysis game. So I would like to encourage people to build testing tools based on top of observability data, but I don't think OpenTelemetry as a project should do that. So that's the current state of stuff. If you would like to know more about OpenTelemetry, if you'd like to do a deep dive into the actual project, and you hate the internet, I would like to suggest this great concept called books. There's actually a number of great books written on OpenTelemetry. These two books are good. I've read them both, but they're both written by villains. Who are these people really? Can you trust them? I don't know. So really, the book you should be looking at, if you want to learn more about OpenTelemetry from the perspective of this talk that I just gave, like a more high level, where is this going? How do I roll it out? That kind of stuff. This book that I wrote with Austin Parker is a good one. So, trust this one, use this one, buy this one, send us money, make us rich. Thank you. That's my pitch.
Pretty awesome.
Love it.
Thanks.
And this is being recorded.
So, thank you. I think that profiling, a lot of the work happening in profiling is very exciting when you kind of fast forward a little bit. Like I think I think as I've watched eBPF over the last couple of years uh, come to the forefront of things, and the cost of collecting profiling data more efficiently, I would assume, will go down. You know, both in terms of our ability to have hardware that can have some accelerated, you know, processing of it in real time, but just profiling, at least if you go 20, 25 years ago, profiling was a thing where, kind of to your point, you do all of this work and then you kind of have some idea of what's actually going on. It's down in this module, it's down in this set of code. Now I can do profiling because I can only profile for 20 seconds before my disk is full. You know,
Right.
and if I'm running at scale, there's no way I could profile everything all the time. But
Yes.
I think that is become flipped, right? And as we have more capacity and we're more efficient with things, I think we can start using profiling earlier in that process, you know, like to build like a fingerprint, or sort of like a what does normal look like. Now profiling data can kind of help us, you know, winnow down the possibilities in a way that just wasn't pragmatic before, unless you had just way more money and storage than you think. But what do you folks think? I mean, you know, Alalita and others, you guys have been running observability systems at scale. Do you think that's still like far away, or do you think do you think we're getting to the point now that 2024 is almost done? You know, now can we really start looking at this viably for larger systems at scale, or is it still sort of parked way at the end of that workflow cycle?
I think profiling is going to continue to become more and more integrated and important in the observability stack. It's already happening, but the primary, two hurdles, if you will, that we are facing today are one is integration. That is, how do you interpret profiling data with, other data, telemetry data that is coming in, and there is still visualization as well as analysis layers being built to better interpret that. But the other area also is that, as and here is my favorite plug here for some of the work even Hotel is doing, is that as AI applications become more and more pervasive, profiling also becomes more and more important, because again, just as tracing, software is no longer just code. Software is actually more than code. And in that paradigm, you do need to understand, what your application as well as what your models are doing. And there is where profiling as well as tracing become more and more important.
I wanted to add to what Ted was mentioning, and something was missing there, and I'm still think it's really important to consider security, because you're running a code and you have a lot of things going on that could damage the way your code is working. So having a security part of the observability stack, I mean, I think it's like a need. I think now security we can deal with logs or other stuff, but I was trying to ingest or taking the SBOM files and feeding it back as an example, but it's very expensive at the end. And then you store the data, but you need only once or twice. But yeah, I think security is also an angle that needs also be part of that envelope, like testing, like you mentioned.
Yeah. And it's not quite observability, but there are these things that are kind of hover around observability, in the sense that they are cross-cutting concerns that really benefit from certain kinds of context that traditionally was really hard to get. The number one being this transaction level context. Like, I think the biggest service that OpenTelemetry has done the world, honestly, is coming up with like a tracing system that is installable without, just an absolutely epic amount of work. Because once you get that installed, OpenTelemetry kind of pulled out this fundamental of context propagation. And so you can make use of that for other domains. Security is important, but I would say security needs to be tightly integrated with observability, like Henrik was saying. But you also have like control flow. You know, people refer to that as like A/B testing and stuff like that, but that's really control flow, and that should not be in observability, to be clear, right? But control flow, making use of that context propagation once it's there, that's a lot of valuable data. And you can absolutely see operators, for example, being able to, if they had more control flow available to them, that would help them potentially, you know, remediate or mitigate issues, right? Like you could see them getting an extra couple of tools in their tool belt, if they had more, if they had a control plane connected to control flow in a way that worked a bit better than what they currently have. So there really is a lot there once you've got this context propagation going that you can do. And kind of on that same note, just circling back to profiling, one of the things that you can do once you have context is you can be selective with how you sample your profiling. Same thing goes for logs, right? Like there's a lot of sampling that you can do in a way that's very intelligent. If you have a backend that's able to actually, you know, be kind of a control plane for all of this observability. And if the profiler is connected to the tracing system, right? If it has all of this context, then you can think about ways to actually like really effectively blanket your system with profiling in a way that is like not costing you an arm and a leg, right? It's possible to start finding a better balance in terms of like what kind of profiling you're collecting in production in a way that's cost effective. It also gives you the ability.
Dynamic and reactive, you mean?
Well,
like I see something here, I can have some rules like, oh, okay, well, you know, we've got more errors here, so let's beef up profiling there.
so there is that, right? There's what I would call like soft dynamism, right? Which is just making sure you're not collecting a lot of duplicates, right? And so you can dial back the percentage of how often something gets run effectively, so that in the back end you have at least one copy of each kind of bit that was executing. There's also the like, as I'm hunting around in the middle of a fire, right? And I'm trying to like drill in on certain parts of the system, like triggering, you know, more dynamically and heavily, triggering more profiling. My only concern there is like the last thing you really want to do when your system is in an unknown state is like jerk it around and change the load on it and things like that. So I've always had like a bit of concern that there's a foot gun there, but there's also like a huge amount of value in being able to do that. So I think that's just a good example of like where we need to like not just theoretically figure it out, but there's like a practical level of like how do we give end users the best value with like the minimum amount of buckshot loaded into the foot gun. I don't know that there's like, I'm sure there's people have thought a lot harder about that particular problem than I have, but it seems like one of those open questions. But you could do it now more effectively than you could if you didn't have a great way of being like, this operation is errors, or this is where I'm seeing a lot of latency here. So my coarse-grained system, like, all right, start collecting me when you see like spans coming in up here, way up here. When I see something up here, I want that to like pop something into my context propagation that tells this span down here to start collecting more profiling data or something like that, right? Where you're able to be like, I see the symptom, now start telling me more about this thing down here because I suspect this is where the problem is. Without having to like carpet bomb your system by saying like, just collect everything over there and I'll paw through it later. You could be more selective, and maybe that would mean you're not putting as much pressure on the system. You're not really changing its load as much as you might if you didn't have those tools, and that might make it a bit safer to do that kind of dynamic investigation.
Sure. I think, yeah, those are good points. I think there's also like not quite as stark of a line between analysis and collection as perhaps we used to have originally. Like you know, when you've plenty of folks that I've talked to, including myself in previous roles, like we had metrics sort of out of the box, you know, in terms of like we already have this life kind of started with metrics in many organizations, and then logs kind of now become like brought in as well. And with those two things, your correlations are oftentimes labels, right? That you're as an organization, or maybe you got some labels for free, you know, because you're using other components that are already instrumented. But when you start adding traces and profiles and events and everything else, I think that those separate streams of data, I'm not sure how useful for OpenTelemetry positionally it is to kind of take a hard line necessarily and say we don't do analysis, like think processors in the collector, right? So some of this correlation could be happening in line real time.
Well,
You mentioned walking a graph
I
between
think, Matt, it already does, right? In the
right.
sense that there are many ways processors are used in the collector. There are many ways that they're extended to do aggregations as well as cardinality management.
Right.
And
Things that used to
that'll
only happen in
continue to,
backends,
yeah,
right?
exactly.
And and so the way we want to look at that is a control plane. So
Yeah.
OpenTelemetry is developing a protocol called OpAmp, which is the control plane protocol, starting with collectors, but also the SDKs, you know, the clients embedded in the actual applications, so that you can dynamically reconfigure these things. We try to draw a line between the actual analysis tool and the telemetry system here, because we think we can standardize telemetry, but like, you know, the analysis is really greenfield. But yes, there's all this stuff related to sampling and other things that in my opinion humans should not be involved with. I think sampling is like the biggest example there, and you could put profiling under that bus as well, right? Like if the humans are like manually configuring the sampling a system is doing, that's it's at best overly expensive, and at worst you're screwing up your tools. This is an active worry I have, because I see people, you know, we put this stuff into the collector so people can do all these different kind of like tail-based sampling and head-based sampling and flip this coin and all of that. And then they're looking at statistical data in the back end. And I worry that if that back end doesn't know about the kind of sampling you've put there, it's very hard to figure out that your statistics have skewed when you're using your statistics are the only way you can observe
Right.
your
It's like,
system, right? So
yeah,
that has always been a big worry to me. But if that backend, that analysis tool can drive the sampling, it knows what data it needs to do its job, because different analysis tools need different amounts or types of data to do something useful. So if that thing can be dynamically updating even just the sampling rules everywhere, that would be huge cost reductions, and way less hair pulling on the part of the operators, you know, trying to figure this out. So you're totally right. Like there is absolutely this feedback loop that needs to be there. And OpAmp is our solution for that, hopefully.
interesting. Henrik, you had raised your hand in the middle of that.
I
Wasn't
was
sure you-
saying bye to Ken.
Oh, I'm sorry. I thought you were like me. Yeah, I'd love to hear more about OpAmp in the future. I'm not intimately aware. Um, I think too, something you said kind of has been tickling the back of my cranium since you said it, where you said, you know, you kind of want to walk these different signals and the data like a graph, and that's kind of what we do mentally, right? We kind of see something and we connect it to something else. But it occurs to me, Alalito was talking about, and we've been talking in the last couple of months about what's different about AI applications, but both from an application perspective, but also as a workload. And when you start thinking about agentic systems or teams of AI working together, suddenly these interaction patterns are a really nice fit, it seems to me, a casual observer, uh, to fit sort of the notion of spans. And it got me thinking, like spans in traditional microservices is always, looking at latency and looking at where's the long, where's latency happening and what's actually happening. But we kind of, most of the tools that I've seen and most of the visualizations of this take a very sort of like a linear view, almost like, you're reading a dev spec and it's got, a back and forth diagram, or you can see kind of on a linear timeline, but it's always just that one dimension of like time is left and right and all the things happening are up and down. And like, it's like a plane slicing through a complicated 3D system. And so,
Yes.
so like when we think about like microservices talking to each other, or working with each other, or agents or whatever, like our software running, these signals kind of, in my mind, form not a linear thing at all, but they're kind of like almost volumetric. Like, where are we spending time? Where do things branch out generally? And where are the outliers? And I think we have some opportunities for both data reduction, it's not compression, but it is, and it's not deduplication, but it's kind of all of those things. Because if we're thinking about like, well, what are the common shapes we see in that branched out graph? Like, that shape itself is something that is sort of, it's lower fidelity but higher meaning, right? And so
No,
like,
you've really nailed it, Matt. In fact, well, one, it's like clearly we need more than two dimensions, right? So in the future,
this has
observability
always been in people's
kind of
wetware.
VR nonsense, but no, like actually Jaeger had a great shape analysis tool is like one example of this. I'm sure other systems do, where you could look at you could compare transactions and it would show you the diff of the shapes of those transactions. And that kind of visual diff
Between
was
two
like
versions of
very
software.
good for a human using our visual, find the fruit on the other tree pattern matching thing to be like, oh, I see the way these are diverged, something is catching my eye. But you could see like a machine learning system also doing that kind of shape analysis, right?
Yeah.
So you're totally right. There's different kinds of ways of looking at these systems, and it's just having a human do that stuff. We're very good at it, but we don't scale very well.
Well, yeah, and when you're talking about holding up a ruler to the screen, I've always kept a pair of drumsticks kind of near I drum since I was a little kid, and I
Yeah.
fidget. So like I try to like do it out of sight so I'm not distracting in meetings. But I can't tell you the number of times I've literally like done that.
Right.
Like held but again, that's only on the time dimension, and it's
I can
only
only
it
do
only
that to
works
like
if you line
5
up all the
things
windows that.
right? Right. It's just like my dashboards can only get so big if I'm a
And
human.
I've lost years of my life doing that, and it does not scale, and it's a burnout job, right? And even then, we're just looking at one dimension at a time. So, like, I really think there's an opportunity for like some sort of computer sciencey approaches here, GNNs or other things, just different ways, even more simple things than that, to help us visualize that, but also kind of help with that really like computationally hard thing for humans to do, and um,
it gets rid of the scut work, right? Like that's the thing. This is the thing in practice that I've observed. The shift really that I've observed is the way we traditionally did this. And I mean, I've been doing this for 20 years, right? Like the same thing where anytime I want to make a hypothesis and then I want to check whether I'm right, the amount of time and effort I have to spend collecting the data I need and like grepping through it and reducing it into something useful is very expensive, right? And so what we've developed naturally is like a very, very reserved, conservative approach to making hypotheses, right? Like an part of being an operator is really smart about like, where am I going to play my cards? Which of these lines am I going to investigate? Because it's going to take me a lot of time to even get the data to even check. But if you've eliminated that time, right? If you've really reduced the amount of time it takes to be like, I wonder if it's this or this is connected to that. If I can move quickly there, even basic things where it's like, I see this error, show me all the logs in this transaction. That used to take a lot of time just to winnow the logs down to be like, I think all of these logs are mostly from the same transaction or similar ones. Like that used to take a fair amount of time to do. And if that takes no time at all, then you can start going around this loop really fast where it's like, I make a hypothesis, I go check it. I make a hypothesis, I go check it. And there's this like quantity into quality transition that I observe people do, where once they realize it's like very easy to check things, they become much more aggressive about checking stuff.
Yeah, there's that's absolutely, there's organizational dynamics that at play here too.
And
Like,
yeah.
I'm sorry, I'll leave it after you.
No, I just wanted to say that that's where, you know, correlation matter becomes more and more important because, you know, people actually start thinking that correlation is doable, right? And is actually going to result in a real root causing rather than hypotheses only.
Yeah.
Yeah, I was gonna say, like, plus one to everything you said, and you're kind of speaking from a place of someone who can understand what the way you were saying is like it's all about like what you're doing as someone diagnosing something or debugging something or figuring out the systemic behavior in organizations, particularly like for the operator part of an organization, right? They're running workloads that they don't always understand. So there's also this like human budget of like, when can I go bug the dev teams? You know, when can, our team has found these anomalies and things are down. And if it's not like a complete pandemonium situation, it's like you only have so much social capital, you know what I mean, where you can kind of go to a team and because they're busy building the next bugs, you know.
Absolutely.
And so you end up with this like these incentives that don't really get to systemic throughput, right? Where like the incentives are not to like necessarily go randomize someone and say, hey, I think I've found this correlation. Can you help me understand what's happening with this code, right? So when you scale these organizations up and suddenly all of the individual steps that you were talking about as you're going through things, that might be like, stop, I have to go get another team, you know, and then they're not making a lot progress. So I think that much like compliance or the cost of chasing down security bugs or chasing down figuring out if the CVE matters to us, like there's these non-technical, very, very, very tangible choke points on overall organizational throughput that are not obvious. But observability and tooling and these workflows you've been talking about are like critical path for like, do we ship this quarter or do we ship next quarter? And then the people that have to make the decisions about are we going to spend time here or there are the least informed oftentimes about. Yeah, so have you seen that play out as well? And any thoughts there?
Yeah, I mean, again, it gets down to like, I don't have time to dig into, you know, especially in the land of microservices. It's like, I don't know anything about this, and it's going to be very expensive for me to dig into it. But also, like, we don't, in my experience, like, the number of times, like, a big problem in production is just a straight up logical error,
Oh, yeah.
like just a straight bug in a code, those are the kinds of things that like testing does a great job of catching. And even when you get it in production, remediating that's pretty quick. It's like,
Yeah,
I got an error, right? That's a pretty great breadcrumb. And then it just leads back to something dumb happening, and then you go fix it. The real problems we have are the ones where there's resource contention or configuration, things that are normally independent, no longer being independent and interacting with each other. And you can't see that. You can't see that by looking at the logical transactional path, right? I'm thinking like and it's often something dumb.
So
Like
issues of
thinking
saturation.
back to like when I had a huge problem and you finally figure it out, it's like the system clock on this one server is off, by like 10 minutes. And so like SSL or signing something is dumb when it
Everything stopped for 60 seconds. What's going on?
right,
Wait for
or like
everyone here.
some particular thing is configured, and like the amount of like effort and hell you go through, and then you finally figure out it was that's the kind of stuff that machine learning really would help with, right? Because it would be trivial for a machine learning system to be like, hey boss, like they all come from over here, and what's weird about this box over here is like this like time thing. I don't even know what time is, but like this one thing is like different from all the other things. And just knowing like what's different, which one of these things is not like the other, like that is like, these systems are too big for a human to paw through and figure it out. Like, again, we don't scale. But that's like, you don't even need to call it machine learning or AI. It's just statistical analysis, right? It's just large scale statistical analysis. And it just seems like it's like necessary at this point, given the size of the systems we're dealing with.
I used to have a sign on in my team's area that I would put up that had like a little flow chart, for people coming to my team for help. We were an SRE team at the time, and it was like, do you have a crash? Oh, come talk to me. Is it not like a crash? Like boom, like with a stack trace. Then please write an email, describing the system and your services, and like give us some background, because it's not really actionable right there without all of that kind of context.
Totally. I mean, again, I think as Ted said, most ML today is statistical, large scale analysis. It's really when you start getting into really very large scale systems and large scale networks that you actually start looking at why humans don't scale there. But Ted, thank you for joining
you so
in
much.
today. Really appreciate it. And again, we'll definitely make the recording available, and as well as try to kind of pull in more of the SIG, hotel end user SIGs also to get more involved. But again, look forward to hotel also, participating more. So all good. Thank you again.
Awesome.
And Matt, do you want to wrap up?
No, I was just saying my biggest takeaway from this is opportunities abound. Like,
Yes.
the year comes to a close.
There's a lot going on in
so much happening
observability.
in observability.
And one of these days I'm going to ask Ted about observability 2.0, the confusion around it.
Yeah, I've been reading about some of that.
But that's another talk.
That's another talk another day. But I do feel like we're unlocking skill trees. Like
Yes,
now that we
totally.
have these sort of ubiquity in these areas, now we can go actually, do what's
Go
next.
figure.
Anyone talking about observability 2.0 is a charlatan. Don't listen to them.
Exactly.
Including me.
All right. Thanks, everyone. Thanks, Ted. And we'll
Thanks.
definitely share the recording.
Have a great holiday, everybody.
Happy holidays.
Here.
Bye.
Bye.
Bye.